Hello chemists and lovers of chemistry, welcome back to our channel. If you are a returning subscriber, thank you for always coming back, and if you're here for the first time, please do well to subscribe, share, like and comment. Also tell a friend to tell a friend that this is Chemistry at a Glance with Treasure, where we teach chemistry at its simplest form. Today, our topic is separation techniques of mixtures. Substances which contain particles of only one kind is called a pure substance. This simply means that the substance is homologous in nature. Mixture. Substances which contain particles of different kinds is called an impure substance or mixture. A mixture is made up of two or more pure substances. This simply means that a mixture is heterogeneous in nature. The pure substances which are present in a mixture are called components of the mixture or constituents of the mixture. The components of a mixture retain their original properties. A mixture shows the properties of all the substances present in it. For example, air is a mixture of gases such as in oxygen, nitrogen, carbon dioxide and water vapors. Air shows the properties of all its components. This simply means that you cannot talk about air without talking about what it is made up of. Each of the constituents of a mixture still retains its individual property. Therefore, we can utilize this to separate them. Let's look at the types of separation techniques. The first one is sieving. Sieving is a separation technique which is used to separate solids of different sizes. It is employed in garri processing industries and other industries where sieving is highly needed. And we commonly use this type of technique in our homes when we want to sieve out our parboiled rice from the dirty, starchy water. Another technique is decantation. It is used in separating a mixture containing a liquid and solid particles into two distinct layers on standing. Example is sand and water. Perfect example we use in our homes is when we want to remove dirt from the garri we want to smoke at home. So looking at the diagram, we can see that the sand is at the bottom layer of the beaker while water is at the upper layer of the beaker. So the process of removing the water from the sand is known as decantation. The next technique is evaporation. It is used to recover a solid from a solution. Example is recovering salt from a salt solution. Now this technique is used in salt producing industries where they take salt solution from sea water, take it to the industry and apply this very technique. So the mixture of salt and water, which is the salt solution, is boiled in order to make the water evaporate, leaving only the salt inside the dish. The next is separating funnels. It is used to separate two immiscible liquids. Example is kerosene and water, and another perfect example at home is oil and water. Now looking at the diagram, this is a separating funnel that has a stopper and a stopcock. This stopcock serves as a tap to avoid the liquid of lower density into entering inside that of high density. Another technique is magnetic separation. It is used to separate magnetic substances from non-magnetic ones. It is employed in steel industries and also used by carpenters in their workshop. Here now, looking at the diagram, sulfur and iron filings, you separate it using the magnet. The next technique is filtration. It is used to separate soluble particles from liquids. It is used in water purification plants and breweries. Example is chalk particles separated from its liquids. Looking at the diagram, The chalk particle is separated from its liquid using this funnel and the filter paper in order to get our filtrates. Another technique is sublimation. It is a process whereby a substance changes directly from solid to gaseous state without passing through the liquid state. So it is employed in the separation of any substance that sublime like iodine and ammonium chloride. So looking at this diagram, in the separation of iodine and ammonium chloride, you will heat it in a dish with a Bunsen burner. Then the ammonium chloride will now evaporate, and when this evaporates, it will form a solidified ammonium chloride inside an inverted funnel which is being covered with a cotton plug. The next is distillation. It is used to remove a solvent from a solution. The solution is heated in a flask to vaporize the solvent. Example where this technique is used is in the processing of distilled water, and this distilled water is commonly used in a lab preparation, especially during titration, to avoid getting results that have errors. Now looking at the diagram, we have a distillation flask with a condenser, Bunsen burner, retorts stand, receiving flask. All this makes up the distillation materials. The next technique is fractional distillation. It is a form of distillation that is used to separate solvents based on their boiling point from their solution. It uses fractionating tower or column. The difference in boiling point between successive fractions must be more than 10 degrees centigrade. Now, looking at the diagram, everything in distillation is also applicable here. The only difference is this fractionating column. A perfect example where this technique is used is in the oil industries, where oils that are being drilled are processed. Now, when processing this oil, you will find out that from the oil we will get our gas, kerosene, diesel and fuel. The next technique is chromatography. Chromatography is used to separate mainly colored substances and also non-colored substances. Here, a solvent moves over a porous absorbent medium to separate a mixture of solutes. Looking at the diagram, this is thin layer chromatography and column chromatography. From the point of origin, you will find out that the sample of reaction mixture in a solvent is separated into three colors, of which they are orange, pink and yellow. Let's look at the type of chromatography, its application in the real world, why and what is it. The first one is liquid chromatography. Where is it applied? To test water samples to look for pollution. Why and what is it? It's used to analyze metal ions and organic compounds in solutions. It uses liquids which may incorporate hydrophilic insoluble molecules. The next is gas chromatography. Its application is in the detection of bombs in airports, used to identify and quantify such drugs as alcohol, used in forensics to compare fibers found on a victim. Why and what is it is used to analyze volatile gases. Helium is used to move the gaseous mixtures through a column of absorbent material. Then the next is thin layer chromatography, used in detecting pesticide or insecticide residues in food. Also used in forensics to analyze the dye composition of fibers. Why and what is it? Uses an absorbent material on flat glass plates This is a simple and rapid method to check the purity of the organic compound. The last but not the least is paper chromatography. Its application is in separating amino acids and anions, ribonucleic acid, that is RNA fingerprinting, separating and testing histamines, antibiotics. Why and what is it? Is the most common type of chromatography. The paper is a stationary phase. This stationary phase means static phase, that is the immovable phase. This uses capillary action to pull the solids up through the paper and separate the solids. Now, the paper chromatography is the most commonly known type of chromatography worldwide. So that is all for chromatography. Another technique is crystallization. It is used to separate salts which decompose on heating from their solutions. The salt crystals obtained in this way are pure and usually contains water of crystallization. It is applied in industries where purity of the product is important, as in the manufacture of drugs and in sugar production. This is where crystallizations are commonly used. Now let's look at the diagram. We have 4 steps here. The first one is to stir the impure solid so as to be dissolved in the solvent. Then after that, the solution is being heated to evaporate most of the solvent. Now the next step is the solution is allowed to cool to obtain crystals. Then the last step is the cold solution is poured off to obtain the crystals by pressing them between sheets of filter paper. The next technique is recrystallization. Here in this technique, it has the same exact procedure with that of crystallization. The only difference is step 4 and that of step 5. The first step is to dissolve the solute in the solvent. The second step is to heat it so that the solute will dissolve completely. The third step is to cool it in order to get a purer crystals. The fourth step is to use vacuum filtration to get pure crystals. Now the last step, which is the fifth step, is to recover the solvents. This is all for recrystallization. The next technique is threshing. It is a process that is mostly used by farmers, in which stems of wheat or paddy are beaten to separate grains from the stems and from the chaff that cover the grains. This is all for threshing. The next technique is winnowing. It is also a method used by farmers to separate husks from grains with the help of wind. Husks is very light, whereas wheat grains are heavy. Winnowing is done using winnowing baskets. The farmer stands at a higher platform from the ground and allows the mixture of wheat grains and husks to fall down from a height by shaking his winnowing basket continuously. This is a self-explanatory method, and that's all for winnowing. The last but not the least technique is hand picking. The method of hand picking is used to separate those mixtures where one of the components is in small quantity. It is also used to separate undesirable substances such as small pieces of stones from wheat, rice and beans. We all use this method at home when we want to separate dirt from our beans and stones from our local rice. This is all for hand picking. This is all for separation technique. Hope you understood the lesson. Thank you all for watching. Meanwhile, kindly subscribe, like, comment and share. It will be well appreciated. Love you all. See you in my next class. Bye bye.